In the previous video, we learned how to name straight chain alkenes. Now we'll name some cycloalkenes. And you'll see that here the system is going to be very similar to naming cycloalkanes. The only difference will be that we're going to prioritize numbering the double bond. In the first example, we see that there are no substituents on this particular molecule. And if there are no substituents, then the system will be basically the same as cycloalkanes with no substituents. And in this case, the double bond really doesn't need a number because there's nothing else to compare it to. So we know that we're always going to prioritize numbering the double bond. If there's nothing else there, then it's kind of redundant. So in that case, notice that this ring has 5 carbons. So we're going to use the prefix pent to indicate that there are 5 carbons. It's an alkene because it has a double bond. So we're going to end with -ene. And it's cyclic. So in that scenario, we use the prefix cyclo to indicate that it's a cycle. And that becomes cyclopentene. And again, we don't need numbering here because there's only one double bond and there are no substituents. So it's understood that that double bond would be on carbon 1. Now, if the substituents are present, then we do need to number things. So in this scenario, we see we still have that cyclopentene as the parent, but there is now one substituent that we need to account for in our name. So if the substituent is present, then we're going to number the carbon-carbon double bond as number 1 and number 2. So one of these carbons will be carbon 1, the other one will be carbon 2. And I'll try a couple of different options. So I could call this carbon 1, this carbon 2, and then I have to continue down in that clockwise pattern. I can't skip ahead and make this carbon 3. That would be strange, right? They do need to connect in numerical order. So if I continue clockwise, then the substituent ends up on carbon 5. Alternatively, I could have made this carbon 1 and then continued counterclockwise. And in that case, the substituent ends up on carbon 3 versus carbon 5. So since the double bond gets the lowest possible number in either scenario, then the way that we're going to decide is by prioritizing the substituent. So in this case, the substituent gets the lowest possible number. In this case, it does not. So we're going to use the lower numbering system. All right, skipped ahead to my next example. All right, I see that the parent here is cycloheptene, not heptene, cyclopentene, just like in the previous example. And I don't have to indicate that it's one cyclopentene because it's understood that the double bond is going to get number 1. So then I just have to list my substituent. And I see that it's a methyl group on carbon 3, so that becomes 3-methyl cyclopentene. Let's try one more. Okay, in this case, the ring has 6 carbons, so I know that the parent here is going to be cyclohexene. And then I have to number this to give the double bond the lowest possible number, and then give the substituents the lowest possible number. So I'll try a couple of options. I could call this carbon 1 and then continue counterclockwise. And in that scenario, the substituents would be on carbons 5 and carbon 6. Alternatively, I could call this carbon 1 and then continue in a clockwise pattern. And in that case, the substituents are in carbons 3 and carbon 4. So I want the option that then gives the substituents the lowest possible number, not the higher number, because in either case, the double bond is on carbon 1. So I'm going to delete the one I don't want, and I'll keep this one. and then I'll name the rest. So here I see I have a 3-methyl. Here we have a 4-chloro. And then I have to list the substituents in alphabetical order, and C is before M. So this will be 4-chloro, 3-methyl, cyclohexene. And that's about it. So it's very, very similar to cycloalkanes. You just now have to prioritize the double bond in the numbering.